Hello, good afternoon. Can you understand me? Okay. Here on the picture you see the fastest way to become DBA. You need only a small tool called Knife and a telephone dictionary. So you visit the DBA at home and then access the company network. But I expect that we will see this in future, but not now. But the talk today is about Oracle rootkits, second generation. And before going to the second generation, I explain also a little bit about Oracle rootkits first generation and advanced versions of first generation rootkits. Then about different possibilities how to implement database rootkits in Oracle. And then some conclusions. I work for Oracle for Red Database Security, and we are specialized in Oracle security only. And it's fun to work with this software. Okay, the first talk about Oracle rootkits I gave last year at the Black Hat in Amsterdam, but my problem was I gave this talk at the 1st of April. So many people thought it's an April Fool, but that's not true. It's real and you can try it at home in your private database. A few years ago I made the observation that operating systems and databases are quite similar in the architecture. In both you have users, processes, jobs, executables, you have even something like some symbolic links. In Oracle you can even change directories. And then I made the assumption, okay, a database is a kind of operating system. And to prove this, I made a small table. For example, we have the OS command ps to show all processes. And in Oracle, the command is select staff from $process. Then we can kill processes with alter system kill session. We have executables like views, packages, functions, and procedures. We have execute command. So by select staff from view, we can execute the view. We can execute procedures, and we can even change something like directory with alter session set current schema. And then I made the assumption, okay, if a database is a kind of operating system, then it's possible to migrate all the malware stuff from the operating system world to the database world. And my first approach was to implement the Oracle virus based on a view, and I implemented this and it worked. It was just a proof of concept. Okay, before coming to database rootkits, what is a normal operating system rootkit? Normal with an operating system rootkit, hackers are using this to hide their presence on a system, or some music companies are using this to protect their music from being stolen. For example, last year, Sony released the Sony DRM rootkit, and this rootkit was hiding every executable containing a $Swiss dollar. So if the rootkit was active, you saw nothing, even in the task manager, and if the rootkit was not active, you could see this executable. The same is also possible on Windows, on Unix. On the right part you see nothing. On the left part you see that the user hacker logged onto the system. And all the rootkit stuff on operating system is quite old and exists since 15, 20 years. Okay, so my goal was, after migrating a virus, was to migrate a rootkit. So instead of using the operating system, we are using the database. Instead of hiding an operating system user, we are hiding a database user, database jobs, and processes. So the most fundamental parts of the database. And generally, there are two different ways to implement a first generation rootkit. The first way is we can modify the database object itself, and the second possibility is we can change the execution path. And I expect the evolution in different types of database rootkits. The first generation, presented last year at the Black Hat Europe, is a modification in the data dictionary. For example, we are modifying a view or changing a synonym to change the content. The second generation, presented here later, is there's no change in the data dictionary, and that's why it's much more difficult to detect. And the third generation works directly on the memory of the database, and Oracle was so kind to deliver an official API since Oracle 10G Release 2 to do this. But this is still future, third generation. First generation, easy to implement, easy to find, but even then, most DBAs never heard of this term and they are never looking for this kind of modification. Microsoft was, last year after they saw the presentation, they changed their SQL Server 2005 and they implemented a simple anti-database rootkit technology. So they're using digital signed views, and if you modify a view, you're getting a warning during the database startup. So Microsoft is taking this serious, and they did their first protection against it. Oracle did nothing. Before modifying objects, we must think about how is Oracle resolving object names. So what happens if you are submitting a statement, select username from DBA users. Then Oracle checks first, is there a local object in the current schema called DBA users? If yes, use it. Normally there is no such object in the current schema. Then it checks for a private synonym called DBA users. If yes, use it. Then for a public synonym. And normally there's a public synonym called DBA users. And depending on the object, Oracle modifies the SQL statement afterwards if virtual private database, VPD, is active. So it's from top down. It checks first in the user schema for table or views, then for private synonyms, then for public synonyms, and then it accesses the original views or tables. And now we have different possibilities to modify the execution path. One possibility is we can create a local object with the same name. For example, in the system schema, we can also create a private synonym or modify a private synonym pointing to a different object. We can create or modify a public synonym, or we can switch to a different schema. All these four ways are able to modify the execution path. Okay, user management. How is the user management done in Oracle? For a historical reason, Oracle is storing users and roles in the same table called sysuser$. Users have the flag type number 1 and roles have the flag type number 0. And to simplify the access, Oracle has two views, DBA users and all users, and public synonyms. So everybody in the database can at least access the all tables, the all users, or if the user has DBA privileges, he can select staff from DBA users. Now we are creating a user called hacker. With the weak password hacker, a good hacker would normally never use the username hacker. He would use something which sounds like an Oracle database account, like mtsys, for example, and he normally uses a better and stronger password. In the next step, we grant DBA privileges to this user. And the problem if the DBA in the morning look into his database and checks all the users with select username from DBA users, we see here that the user hacker is active. And now we try our trick. And here nowadays a lot of DBAs are using graphical user interfaces. So we can see the user hacker in Enterprise Manager and Database Control or in Toad from Quest. And now comes the trick. We are modifying the view DBA_users, and we are adding one single row, and uname not equal hacker. This means show everything except the user called hacker. There are many possibilities to remove the user hacker from the output. So you could also say and u.id not equal 47, something like this. And surprise, after doing this modification, the user hacker is gone in Enterprise Manager and Database Control. So you can't see it. And also if you do a select staff from DBA users, the user is gone. Only Quest Toad is using the user is visible in Toad. The big question, is Toad a better and more secure product? No. Toad is using a different view. So if we modify the view all users in the same way, by adding this end uname not equal hacker, the user is also gone in Toad. You can still log on to the database using the user hacker, but it's no longer visible. And in this case, if you select star from DBA users, you select the public synonym. From there, you access the view, and here in the view, we did the modification. The process management is quite similar. You have also some special views. And with select SID serial number from $session, we see also objects from special users. And then by doing some modification, we can also hide the running sessions of the hacker. The same can be done for database jobs, because sometimes it makes sense if you want to survive an update to set up a database job. And every night you run a database job, and this database job checks if the rootkit is still active. And if the rootkit is not available, for example, after doing an upgrade or a patch, you can implement the rootkit again by running a database job. And that's why it's useful to hide database jobs. Here we create a simple job. And here we can see the user hacker, and his job is active. And now we modify p-owner not equal hacker, and then the user hacker is gone. But it still works. Now I show some examples. To generate a rootkit, you can run the following select statements. Oracle has a package called DBMS metadata. With DBMS metadata, you can generate the DDL statement, the DDL code of an object. So here we say DBMS metadata.get DDL from the view all users. And then we replace the where with where username not equal hacker. And the result of this select statement is written into a file called rk_source. And we are doing the same for the view DBA users. And then two modified views containing this where username not equal hacker are now contained in the text file rk_source. Then with spool off, we disable the spool file. Then we create our hacker with a stronger password, and then we execute the view command. And then we replace the view all users and DBA users, and our user hacker is invisible. From the concept, this is quite easy to find. One thing you can look up in the view, but most of the DBAs are not doing this. Instead of using the view DBA users or all users, you can access the table sysuser $ directly, because then it's, even if someone modifies the view, you can still see the unmodified data in the base table. Okay, if you now try to make a little bit more advanced rootkit, which is much more difficult to find, we can implement a rootkit in an Oracle system package. And Pete mentioned this in his talk before. All the Oracle packages are wrapped and obfuscated or encrypted, depending on the Oracle documentation. And there are also working PLSQL unwrappers out there. And with these PLSQL unwrappers, you can unwrap a PLSQL package, backdoor the package, then you wrap the package again and install this backdoored package in the database. And the normal DBA without this unwrapper has no possibility to find this backdoor. So here is one of the unwrappers available. Here you can specify the package on the file system. Then you specify the type, and then by clicking on the pass button, you get the source code of the entire package. And now in this package, we can implement our backdoor. One of the procedures of the DBMS output package is the procedure enable. With enable, you can enable the output of the database. And in this case, we add some code and we say, okay, if this package is executed on a Saturday or on a Sunday, we grant DBA privileges to the user Scott. On normal work days, we revoke the DBA privileges from the user Scott. And then we wrap this package again, install it in the database, and then during the week, everything looks fine. Everybody has the right privileges. And only on the weekend, the user Scott has DBA privileges. And most of the security audits are done during the normal business hours, so it's quite difficult to find such a kind of backdoor in the database. The only possibility to find this are checksums. So similar like Tripwire, you need a tool to do checksums in the database. Yesterday I had a discussion with Pete, and he had also an interesting idea, and I included it in this presentation. He called it port locking. By sending a special string to a package, you can activate the Trojan on the system, for example, to create a reverse shell. And this is quite easy to implement. So here the same package, the same procedure, enable from DBMS output, and here we say if the buffer size is 31337, then we are modifying the password of the user Scott and grant DBA privileges to this user. And in all other cases, we revoke the privileges. So by sending one special parameter to a database package, we can activate the backdoor. We could also implement the reverse shell. We could start operating system commands, stuff like that. And also, again, wrap the package, install it in the database, and during a normal security audit, nobody will find it. This is quite useful if a hacker works on an unpatched database. So in this case, he can install a backdoor, and if the database is patched in the future and the security vulnerability is fixed, he has still the possibility to become DBA on the system. Any questions so far? Second generation. The second generation is a little bit more difficult to implement, but also more difficult to find. Sometimes you need special accounts to be able to find these modifications. Because in Oracle you have different groups, and only the sys account is able to see all the data and all the information unmodified. Oracle has some functionality called virtual private database, and virtual private database is able to modify select statements afterwards. So you run a select star from table, and Oracle automatically adds a where condition. And this can only be deactivated by having a special privilege, exempt access policy, or if you are a sys. I found different ways to implement the second generation rootkit. So this time we don't modify a view. We are trying to implement a modification without modifying the data dictionary, where all the packages and views and stuff is stored. The first idea, it's quite easy to implement, is we can implement a rootkit by modifying the binary. So what happens during a normal login process? The Oracle executable is looking in the table sysuser$. Then he reads the username and the hash value and compares this data with the login data. The question is, how does Oracle know to look up in the table sysuser dollar. It's quite easy, it's somewhere written in the code. I'm not a reverse engineering expert. I'm using the poorest man reverse engineering tool called UltraEdit. So just by opening the Oracle executable in a text or hex editor, you can search for the string sysuser dollar. And in Oracle Express Edition, you have 106 occurrences of this table. And then I used the simple trick. I said, okay, replace sysuser dollar with sys.aser dollar. And then replace everything in the file and then store the file. Now if you log on to Oracle, Oracle is no longer looking in the sysuser dollar, Oracle is looking in a totally different table, aser dollar. And if the old table still exists, the security auditor or the consultant or security tool is looking in the wrong table. So it's looking for a new user in sysuser dollar, but this does not work, or the user is not available. But if you log on with this hidden user, you are accessing a different table. So here we create a table. Then it's important, before we do the modification, we must create a copy of the table sysuser dollar. If you don't do this, you're not able to log on to the database anymore. And after creating a copy of the table sysuser dollar, we'll create table sys aser dollar as select star from sysuser dollar. We are dropping the user hacker from sysuser dollar. So now we have one row more in the new table. Then we shut down the database, and then we replace the name of the table twice. And then after doing this, we can log on to the database, because Oracle is looking in the new table, but all the tools and all the security auditors, they have the sysuser dollar or the view hard-coded. So in this case, we don't have a modification in the data dictionary, and we have an invisible user. And here again, the way how to do this, create a user with DBA privileges, create a copy of the table. Then we drop the user hacker from the old sysuser dollar table, and we shut down the database, patch the binary, and start the database. The protection is quite simple, but Oracle must do it. One thing is Oracle should sign their binary file. So as far as I know, is someone from Microsoft here? Microsoft protected their binary files, so you are not able to modify these binary files by patching them with a text editor. And I would also recommend to get rid of all the clear text SQL statement in binary files. Normally there's no reason that you can see a simple select statement in a binary file. And using this technique, patching SQL strings in binary files, you can also hack a lot of databases if you do this modification on the client side. Then you should use checksum tools like Tripwire on the operating system to find modification. And here it depends on your level of paranoia. So if you're working in a high critical area, I would recommend to do this. And a few minutes ago, before the talk started, Pete mentioned that Oracle is now delivering Tripwire with the database. Is this true, Pete? No? Okay, so we will check this out later. And you should also harden your database, because if your database is hardened, then it's much more difficult to become operating system access. And you should also check your binary files after you have a new DBA. For example, if your old DBA is gone, then you should check the entire system for modifications, because you cannot never guarantee that there's no backdoor in the system. The second possibility, so in this case, we are modifying the binary files. And there are many other possibilities. The second possibility is called PLSQL native. Since Oracle 9i, there's a new feature called PLSQL native, and this allows to convert PLSQL code into C code. This C code is compiled on the operating system level, and the result is a DLL. And Oracle calls this DLL or library instead of the original PLSQL package. And the problem is Oracle does not monitor the files in the file system. And in 10G, these files are stored in a CLOB field in the database. In 9i, this was also one of the easiest way to run operating system commands. Because by using alter system command, you could specify the name of the make utility. So by using an alter system set PLSQL native make utility, if you set this value to calc, then every time you compile a PLSQL program, the Windows calculator pops up and tries to compile the binary. And in 10G, this was changed. Now in 10G, Oracle is retrieving the compiler information from the registry or from the environment on Unix. And then the compiler syntax is stored in a text file, spnc_commands. And this is the command, this command is executed, cl.exe, %source, no logo, and so on. This is also a possibility to implement a backdoor if you replace the cl.exe with something else. This command is executed. So if you replace this with a shell command or a format command, this is executed if you run PLSQL native. Okay, how does it work? First, you must set, if PLSQL native is enabled, you must set the compiler flags with the alter session command to native. And then if you create or if you alter a procedure, Oracle generates a C file on the operating system first, and this C file is compiled into a DLL. And here's an example of such a C file. Quite unreadable, and I'm not aware that people had a deeper look in this. And this is executed, and this is this PLSQL code from the package. Okay, how can we implement a backdoor? And in 10G, after the DLL is generated on the operating system level, this file is imported into the database and stored into a CLOB in 10G. But even then, here you can modify stuff. This is a part of the C file. Okay. Now we can implement such a backdoor like this trigger if we send a special parameter to the system that we destroy the database or generate a shell. And now we did a modification in the data dictionary. So we have traces in the data dictionary. But first, Oracle generates a C file. This C file is compiled. And then from this compiled file, we are generating a backup. Then we have a backup of this DLL. And the next step is we remove our Trojan from the PLSQL procedure, and then Oracle again generates the C file and generates a DLL. And now this my procedure in the database does not contain any modification. So the checksum is not modified. And now we have the DLL without the modification, and we have a copy of the backdoored system. And now we replace the unmodified DLL, and every time someone calls the unmodified PLSQL procedure, Oracle is executing the backdoored DLL on the operating system. This happens because Oracle does not monitor the system, the DLLs on the operating system level. So it's up to the DBA or developer to delete these files. And in this case, we don't have a modification in the system, but Oracle is executing something different. The good thing is most people don't use PLSQL native. For some special cases, you can have a big performance improvement, but I would recommend not to use PLSQL native. And you should also check your database for objects compiled in this PLSQL native mode, because it's not necessary to compile everything in this mode. You can only have some special packages compiled in this mode. And if you need this, you should also check these DLLs and libraries with checksums. So the first possibility, patching binaries. The second, PLSQL native. Now the third possibility, it's quite an old technique called pinning. Pinning is available since Oracle 7, because Oracle in earlier versions had bigger problems with memory fragmentation. So every time you execute a PLSQL package, this package was loaded in the memory. And if there was not enough memory available for this package, if the package was large, you got an error message called error 4031, Bambamina error something. And to avoid this, it was possible to preload a package into the memory. And for this reason, Oracle has a package called DBMS Shared Pool, and DBMS Shared Pool allows you to pin or to preload packages into the memory. The problem with pinned packages is if you change the object, the package is not automatically reloaded. So still the pinned package is executed and the code from this pinned package. Here's an example. We have again our my procedure and the SGA. And now we implement a backdoor in the my procedure. And now with the command dbms shared pool.keep my procedure, we are preloading this my procedure package into the memory or procedure. And now every time you execute my procedure, Oracle executes the code from the memory and not from the database. And now we undo the change in the database. So again, we have no sign of modification, and as long as the database is not stopped, we are always executing the backdoored package. And that's why if you are using databases, you should check if the package dbms shared pool is installed and what packages are pinned. And if you believe you are the victim of a database attack, before stopping your database, you should generate a memory copy of your database. Because if you shut down the database, all the traces are gone. So you have no incident, no evidence anymore. So in this case, you should check if DBMS shared pool is installed, and you should check on a regular basis for pinned packages. Here are some other possibilities. For time reasons, I was not able to implement it, but I'm quite sure that you can also implement rootkits using these techniques. One is virtual private database. With virtual private database, you can modify the SQL statements afterwards. So even if you run a select star from a table, you see only parts of the table. If a virtual private database rule modifies the SQL statement. One possible victim, for example, could be HTMLDB or Apex. It's an application from Oracle which is part of Oracle Application Express Edition, this way. And in Oracle HTMLDB, all the user credentials are stored in a table flows 020100 www flow fnd user. And if you create a virtual private database rule on this table, you can exclude special users depending on the time or something like this. And the only way to get rid of virtual private database and to see the real content of the table is you must work as sys, or you need to privilege exempt access policy. But if you do this, you disable the entire virtual private database concept. So at least if you do a security audit, you should always work as sys or with this exempt access policy. Only then you can guarantee that you see really everything, the real information, not modified or tampered information. Another possibility, Oracle is full of these features and functionalities, is called query rewrite. With query rewrite, Oracle is able to modify statements. For example, the user submits a select star from table A, and Oracle tries to optimize this statement, and if there are, for example, materialized view, Oracle completely rewrites the statement, replace object names and so on. And Oracle is replacing the select star from table A with select star from table B. And if you have a modification in table B, you can show something different. So this is also one possibility. But this is also not enabled by default. It depends always on your configuration, what you are using. Third generation rootkit is much more difficult to implement. Since Oracle 10G Release 2, there's an official API, and this API allows you to modify the SGA. So you can directly modify all information in the memory of the database. You can modify blocks, you can modify statements, and so on. To do this, you must run an operating system program, and with this program you attach to the database SGA, and in this system you can modify objects. And Oracle is doing this for support reasons. So if you have a problem with your database and you are not able to run select statements, then you can directly attach to the memory and try to resolve the problem in the database. One of the problems of database rootkits is the question, how can you survive updates? Because nowadays, every 3 months, you have critical patch updates from Oracle, and even if you don't apply every critical patch update from time to time, you apply, or you should apply, critical patch updates. And during this update, a lot of the objects are recreated from scratch. So, for example, you recreate views, you recreate packages, you overwrite packages. And then the question is, how can we survive this? One of the possibilities is we can create a special database job, and this database job checks every day or every hour for a modification of the database objects. The second possibility, we can modify the glogin.sql on the database server. This file is automatically executed if someone connects with SQL Plus from the server to the database. And then this code is executed automatically in the background. Then we could also create or modify a database startup trigger. So whenever the database is restarted, we can check if our modification is still working. We can pin packages, stuff like that. Or we can backdoor custom PLSQL applications. Because in most companies, the PLSQL code is not only coming from Oracle, it's also coming from customer applications. So if we implement this backdoor in a customer code, this is normally not modified during an Oracle patch update. And normally it's always a battle between good guys and bad guys. If you say, okay, in this case we are doing that, there's always a possibility to survive such a modification. Finding rootkits, checksums, checksums, checksums. You should have checksums on database objects, because as long as the packages from Oracle are wrapped, you have no possibility to see what's inside such a package if you don't have these tools. Then you should also check some binary files, but it depends always a little bit on your level of paranoia. If you have hundreds of databases, not every database must protect it this way. But it's up to you to decide, okay, this is a critical database, and we try to avoid modification. Sometimes you can also compare the checksums afterwards. If you believe there was an incident, or if you have a change in the DBA group, you can check and compare the checksums. And normally two identical patched database systems should have the same checksums of the PLSQL packages and executables. Then you should check if PLSQL native is active, and if someone is using it. You should also check for DBMS shared pool, and the best protection is always harden your database and apply the latest security patches. And change your default passwords. So from my experience in security audits, in many companies there's no need to install a database rootkit, because in most cases you can log on with DBSNMP, DBSNMP. But in the future we will see that more and more databases are becoming stronger, and even Oracle is making sometimes smaller, sometimes bigger steps ahead. In their systems, 10G release 2, with the latest patch set, it's quite difficult to hack these systems if the system is hardened. So Oracle is a powerful database with a lot of features and functionalities, and that's why you have also the possibility to abuse these techniques and functionalities. And the hacker, internal or externally, can use these functionalities to hide his presence in a hacked database. Questions? Comments? Okay, thank you.